A solid has a circular base of radius 2, and its parallel cross sections perpendicular to its base are isosceles right triangles oriented so the endpoints of the hypotenuse of the triangles lie on the circle. Okay. What is the volume of the shape? Assume the area of the triangle space is b squared over 4, and the base is 4 sine pi over 4x. Okay, so first thing I'm going to kind of draw out what I think is going on here. So maybe a little bit of perspective. So we have a circular base. This is circle, but since we're looking at it at some funny perspective here, it looks elliptical. And we have these triangles here that span the width of the circle. And so each of they're isosceles, so these sides are the same. And then this is the hypotenuse right here. And so what this is telling us is, so looking at straight on, we'd see like a little circle and a bigger circle, and we'll see the biggest circle, and we'll just kind of see triangles when we're looking at it straight on. And so there's kind of like, to draw this I guess again, something kind of like this, up like this, and then there's kind of like a edge of triangle tops going here. And it's saying that the face, the triangle's face, so right here, that area equals b squared over 4, where I think b here refers to this base. And it's saying then that also b equals 4 sine of pi over 4x. Which kind of sort of makes sense because this is a triangle with a, this is a circle of radius 2. Therefore, the maximum distance from one side to the other will be 4. The diameter of this circle will be 4. And so these triangles will range from a base of 0 to a base of 4 back to a base of 0. And if we look at this, if we plug in the maximum and minimum here for the base, it's going to go from, it's going to be 4 long. So if we plug in 0 here, we get 4 sine of 0, which should be sine of 0 is 0. And then if we plug in 4, we get pi over 4 times 4, which would be sine of pi, which would also be 0. So it makes sense that this starts at 0 and ends at 0. So what we're going to do then to find the, what is it, the volume? What is the volume? Okay, so we'll find the volume here. We'll integrate from 0 to 4. And we basically are going to find the, we take the area of the triangle, which would be b squared over 4, times delta x, whatever the width of the triangle is, which will be smaller and smaller, goes towards 0, which will then allow us to do the integral. And then for b, we'll plug in this value here. So really, what I think this question is asking, 16 sine squared pi x over 4 dx. What this question is really asking is, solve this integral. But it looks like they gave us a really difficult question, but then they gave us a couple points of data to make it easier. But the hardest part of this question is kind of situating yourself and realizing, what are they actually asking? It's like a little kid walking into the movie. You have no frame of reference of what's going on here. And so the challenging part here, the most challenging part, is figuring out what's being asked and situating yourself and getting a view. So they're like, all right, here's a shape, find the volume, here's an equation for the face, here's another equation so that you can make sense of the equation of the face. So basically like, that's telling you what the base is right there. And so then we just integrate it from 0 to 4, which is the diameter of our circle. So we're left with this. We look at this, we cancel out the 16 to 4, change that to 4, and now we're left with sine squared. So integrating sine squared is kind of tricky, but we've done it a bunch of times. We know how to do it. We do the, there's some trigonometric identities that I memorize, and I recommend you memorize as well, just because I know I hate memorizing, and I think it's painful and arduous, but such is life in general. And there's some things that are worth memorizing. So this is, there we go. A little bit more. Let's do a cosine of alpha minus beta. Now the difference here will be the sign. Since we're doing sines instead of cosines, we'll change the sign. And then the third one that I have memorized is 2 sine of alpha cosine of beta. And then this gives us sine alpha minus beta plus sine alpha plus beta. And so the way we solve sine here is, what we want is the sine squared of x. So to get sine squared of x, we say, all right, alpha equals beta. And so then we have 2 sine squared of x equals cosine of 0, because if alpha equals beta, then alpha minus beta equals 0, minus cosine of 2x. Okay? And so we have sine squared of x equals 1/2, because this just becomes 1, minus cosine of 2x over 2. And so in this case, then we'd plug in, let's see here. Ooh, actually, I'm going to stick with this above. So I'm going to say 2 sine squared of x equals 1 minus that. I'm going to rewrite our equation over here real quick to be 2 times 2. So now we have 2 sine squared. And so we can rewrite this as 2, 0 to 4 of, what's our equation here? 1 minus cosine, and we have to double this, so 2 pi x over 4, and the 2 is the double, dx. Okay, so we converted a sine squared of x to a cosine of 2x, more or less, with some other steps involved as well. Okay, so this is, now we're on familiar ground. So convert over to blue. So to do this integral, we'll have 2 times x minus cosine of, this is going to be pi x over 2. So we'll have the integral of cosine is going to be sine pi x over 2. And the way I check this then is the derivative of sine of x should have the same sign as the cosine of x. So the derivative of positive sine of x is the positive cosine of x. And so if we take the derivative of this sign, we get that cosine, and they have the same sign. So that's how I check the signs when I take the integral of either cosine of x or sine of x. Okay, so now we need to multiply by the reciprocal of the interior, of the derivative of the interior. This is actually, what we're actually doing here is a u substitution, but this is kind of a quick way of doing it when you have just x there. And this will be evaluated from 0 to 4. So when we plug in our numbers here, we have 2 times 4, 4 minus sine of 4 pi x over 2. This will be sine of 4 pi over 2. Then we'll do a minus 0 minus sine of 0. Get another color out to do some of our canceling. Ooh, dark purple. So this is 0, sine of 0 is 0, 0 is 0, sine of, this is 2 pi, which is 0. And so all we're left with is 2 times 4, which equals 8. Okay. Whoop. pull this over here, and that's even one of our possible answers, which is nice. So, long story short, I know this problem is crazy confusing. Bear with me. It's worth looking at. So, to backtrack where we went, the idea here was we were given this crazy complicated problem. We were then given some pieces of data that we probably could have figured out on our own, but it makes it easier for us. And so we took those pieces of data and we incorporate them. So the pieces of data was basically, we're trying to do an integral to find the volume here. Some sort of, not disk method, but you could call this, I guess, the triangle method. But it works with basically any sort of face that you have an equation for. And so we took this face and we integrated it from 0 to 4, and it was b squared over 4. We then all right, what is this base, which is b, and they gave us, well, 4 sine pi over 4 times x. So we plug that in, we get a sine squared that we have to integrate. We're like, oh, sine squared, so difficult. Yeah. We have some trig formulas that we've memorized, and we plug in to get from sine squared to something that's not sine squared, like a cosine of 2x. We say, all right, alpha equals beta, bam, this equation just kind of falls out. We use that to convert sine squared to 1 minus cosine of 2x, basically. But then we plug in the pi x over 4. We do some integrals. We plug in 0 and 4. Everything cancels out except for one value, which is 2 times 4, which gives us 8. And then that gives us our final answer. So that's how you do this problem. The real challenging part here is just understanding what it's asking. And you get a lot of questions of this feeling on the AP exam where it's like, all right, really hard problem, make it simpler. And you have to realize, oh, they try to make it simpler, and then how to use that tool that the question gave you. Appreciate you guys sticking along. I will see you guys on the next problem. Thank you much, and go team.